A very good afternoon, everyone, and welcome back to the Autocar Professional Vehicle Lightweighting Conference brought to you by Sika and powered by Pioneer India Electronics. Today is the second day of this virtual conference on vehicle lightweighting. My name is Mayank Dhingra, and I will be your host and moderator for the day, where we have a power-packed lineup of speakers who will delve into the details of lightweighting strategies in the automotive industry. As a quick recap for those of you who could not log in yesterday, we had distinguished industry experts, starting with Mr. C.V. Raman, the former CTO of Maruti Suzuki India, setting the context for this event with his keynote address, talking about the design, material, and manufacturing principles for reducing vehicle weight. It was followed by a panel discussion on global trends in vehicle lightweighting, and then with a fireside session with Mr. Anand Kulkarni, the Chief Products Officer of Tata's Electric Vehicle Division, who gave us a deep dive into the various engineering techniques of weight optimization in electric vehicles. We will take the conversation forward today with a panel discussion followed by a fireside chat. So without any further ado, let's start the day with our panel discussion on the topic manufacturing innovations and hurdles in lightweighting. I would like to welcome my esteemed panelists for this discussion. Mr. Johnston, Chief Engineer, Body Structures, Tata Technologies. Welcome, John. Mr. Debanjan Ghosh, Head Automotive and Industry, Sika India. Mr. Arindam Lahiri, CEO, Automotive Skills Development Council or ASDC. Mr. Dhananjaya Boita, Chief Engineer, Powertrain Division, Auto Sector, Mahindra and Mahindra. And last but not the least, Mr. Sachin Bhoutkar, Director R&D, BIW India, Gestamp. Gentlemen, a very good afternoon to all of you, and thank you very much for taking the time out. As the topic of this discussion revolves around the innovations and hurdles in the manufacturing technologies for lightweighting, I would like to start off this session with a broad question as to what are the emerging manufacturing techniques that are enabling lightweighting in vehicles. And if I can begin with you, Mr. Johnston, if you can share your thoughts from a BIW perspective on this.
Yeah, good afternoon, everybody. I'm really pleased to be on this conference, sorry, and I've got a great set of panelists with me. I think it's going to be a very interesting session, a broad spectrum of skills, which is really good. So diving in then. So as far as lightweighting is concerned, it's obviously it's very key as we move particularly into electric vehicles. We carry extra mass through batteries. And also, you know, some of the electronics are a lot more sophisticated, which bring weight with it as well. So the idea is obviously to reduce the both cost and weight. Cost is a key part now because obviously as electric vehicles become more expensive, the focus is to get the body cost and the weight down, both, which don't normally go together. They're normally to achieve lightweighting often involves cost. So over the last sort of 10 years, there's been some really good advances in steels in particular. I'll go to aluminium next, but we'll start with steels. The type of materials used is highly defined by the segment of the vehicle and the volumes as well. And that includes materials and manufacturing processes. If it's a low volume niche vehicle, then more exotic type materials are used and more low investment tooling and investment type scenarios are used. Whereas if you go into the volume vehicles, then the investments are high, and obviously you're looking at more mainstream materials, unless it's expensive premium cars where more exotic materials are used again. So I'll start off focusing on sort of the high volume, lower cost type vehicles, which I've been particularly focused on the last few years. Key to those has been the advancement of modern steels. So as we call it, press hardened steels, hot stampings, and advanced high strength steels such as dual phase. They've been key into meeting the load cases that are required. So with the increased weight of the vehicles, some of the test scenarios like NCAP, for example, global NCAP and Euro NCAP, become very challenging. So the structure needs to take more load because of the weight. So with the adoption of these new steels, these also bring lightweighting themselves as well, because you use thinner gauges, you reduce weight, and they can take a lot more strength. When we move into sort of premium markets, as I said earlier, you have more of a mix of exotic materials. So, for example, maybe 15, 20 years ago, Audi A8, for example, as one example, was almost 100% aluminium car. With the adoptions of the new steels now, they're multi-material vehicles. So the high strength steels are used for key load paths, for crash, for example, because they're much more efficient than aluminium. There are some other aluminium techniques. Obviously, a lot of people, I'll just finish off in a minute. A lot of people are familiar with Tesla's giga castings, mega castings. So they've been adopted by a number of people, mainly premium cars again. Quite a few Chinese companies have adopted them. They've adopted them in various scenarios. Some have not gone for the complete giga castings. They've gone for very complex castings, but where it's more efficient to use sort of thin aluminium panels, they've used it. And for me, that makes sense, because why have a casting, for example, on a wheel arch inner when you can have a very thin material panel? So we have worked with a couple of companies to look at the business case of mega castings, and if they're too complex, it becomes difficult to make it a business plan. That's why there's a real mix at the moment. There's some companies which are going with giga castings and some companies which are not, because the business case doesn't always make sense. Okay, is there anything else you'd like me to go through? I think that's a good introduction.
Yeah, no, absolutely, Mr. Johnston. I think you've touched upon quite a few important elements there, and I will take that to you, Mr. Sachin. Like Mr. Johnston just mentioned, about mega castings, as well as technologies or methodologies like hot stamping. So you being a stamping supplier primarily, I think you are dealing with this on a day-to-day basis. So if you can give us some insights about how you are seeing the transition towards more and more lightweight materials coming into the play, and how the manufacturing technologies are also changing around them.
Good afternoon, Mayank. Thank you for having me for this webinar. Yeah, just to give, I would like to start a little bit with the introduction to our company. So I represent Gestamp. We are design, development, and manufacturer of automobile parts. So we supply majorly the BIW chassis and mechanism parts, with the major focus on lightweighting, safety, and reduction in the CO2. So with that, we see that the technologies are really evolving big time as far as the hot stamping is concerned. We are exploring, and we have developed certain technologies where we now don't need to do laser cutting, but we can do that in our transfer press in multiple operations. That is one area. The other one is also aluminium hot stamping is one area, along with cold stamping, added with composites for sure. Yeah.
Right.
But we see in India, the major traction is for hot stamping, because it is a very good cost to weight proposition that this technology gives. And we have seen in last 10 years, when we started introducing this technology into Indian vehicles, it used to be like 7% of BIW weight. But with this EV, we are seeing now it is over 18% BIW weight. So we see the technology has a very high potential, because it helps to meet the regulatory requirement, the safety requirement, and also do the CO2 requirement, what is majorly the OEMs are looking for.
Right. I'll come to you, Mr. Ghosh. From Sika's perspective, how do you see this transition towards alternative materials? Like we just saw Sachin and John talk about things like aluminum, hot stamping, and even mega castings. So, we are also seeing the joineries becoming different now. You're seeing things moving away from the basic spot welds. So, how do you see from your perspective? You're a chemical company, you're into that bonding space as well. So if you can share your thoughts on this.
Thank you, Mayank. Good afternoon, and Good afternoon to my fellow panelists and all the attendees of this event. It's a very important topic which you highlighted. So maybe a couple of words about Sika since you mentioned about us. So we are a specialty chemical company, and being a leading innovator and supplier to the automotive industry with primary scopes towards the bonding, sealing, damping, and the reinforcing area. So this is what we do. And when you talk about the lightweighting or the use of different kind of materials, and I take some cues from the discussions from yesterday, where again we presented about a bit about the mixed material, and today I also heard from my fellow panelist, Mr. Johnston, about the use of mixed material. And that's where we see a lot of challenges are posed when you combine different material with different, for example, the thermal elongation coefficient as an example, and where you need to have the products designed in such a way that they can accommodate these differentials when the whole body shop is going through the baking and the curing process. When you also talk about the bonding, it is again coming to that when you talk about the overall lightweighting, we look at it from a different perspective that while you do the lightweighting, you also need to look at the safety because we are again talking about the crash and the rating, the Bharat NCAP rating or the Euro rating. So on one side, you talk about the safety, the other side, you talk about the lightweighting. And then we talk, of course, about the reduced cost for production and reduced cost for the on the circularity, or you talk about the sustainability. So when you talk from this perspective, we address these from multiple way. First of all, when you talk about the joinery side, we have the structural adhesives which are specifically designed for the mixed materials, which can accommodate these different kind of product properties to be able to accommodate the movement and, of course, improve the stiffness. And we can also use the reinforcer as an example, where when you use the heavyweight steel panel or you use for the heavyweight structural reinforcer, you replace them with hybrid composites, which are plastic injection molded components with which you can reduce definitely on the weight. And with the CAE predictability, you use less materials. You choose the right locations where you are predicting that where the reinforcement is necessary, and then you go for the right product with a very lightweight construction of those components, and then you install it in the locations where it is required. So that's probably the two directions that we go for when it comes to the lightweighting and the different new materials which are used for the vehicle in today's world.
Right. Very well said, Mr. Ghosh, and I'll take that to you, Mr. Boita. Just an extension of that, the materials that we are seeing today. So you are an powertrain expert. So, from your perspective, what are the different or the new materials that you're seeing now playing a vital role in the powertrain domain to reduce the weight of the entire powertrain of the vehicle?
Thanks, Mayank. So, yes. So it's very interesting. So always when a powertrain comes a topic, whenever a new vehicle is made, what powertrain to be used, then you start with the question, what is the vehicle weight? And then if you go for a bigger size of the powertrain, the vehicle weight increases, intake, exhaust, mounts, everything goes up. So it's a very cyclic. So very interesting topic. At least personally, I have seen when I joined in 2001 in Mahindra, we used to have a heavy engine launched for Scorpio at that time. Then 2001. Then 2007, we launched an upgraded engine. We call it MHAW Gen 1, which is earlier wetliner moved to parent bore construction, optimized material. Then with that, we increased the power and torque by 40%, but the weight is reduced by 50 kg. Then from 2007 to 2017, we got to Gen 2.2 liter diesel engine, wherein we shifted from cast iron block to aluminum block. In fact, I'm proudly say that Mahindra is the first one to launch aluminum cylinder block in a high powered diesel engine, where the performance is almost 30-40% increase. So
Right.
that's happened very high migration to the ICE. I'll talk about little ICE, which is very matured. Then I move to the electric powertrain.
Sure.
So we have seen that a lot of things have happened in the aluminum widely used, and a lot of plastic cam cover, intake manifold, intake cooling modules. Those are the stuff which are pretty much matured.
Mhm.
Along with the CA based lot of topology automation, it has helped us to reduce this weight. When it comes to gasoline Mahindra, most of the gasoline engines we designed in last 7 years, 2015 onwards, we launched many.
Right.
So when we did the engine, we started from the high level system, like for a given vehicle weight. If you go to natural aspirated engine, you can do 50 kilowatt per liter. You go to T turbocharged MPFI, you do 60 to 70 kilowatt per liter. Then you go to turbo GDI, you can go to 80 to 85 kilowatt per liter. So
Mhm.
one is the high level system. What we choose is one thing helps. So instead of
Okay.
going for a bigger engine, 1.5, 2-liter engine, you can go for a 1.2-liter turbo GDI engine with a very high power density. So that is one starting point.
Mhm.
Then you can optimize the system into the engine. So one of the things which helped us with the material is aluminum cylinder head. We used to have exhaust manifold cast iron separately. So we have gone with the integrated exhaust manifold. When you integrate the cylinder heads aluminum, you have a lot of weight saving. Apart from the additional benefit of thermal management and then lambda 1 operation, we can easily achieve. So those are the stuff we did in across all our engine family. So this has helped in across reduction. Then there are many systems related to the oil sumps going into plastic, then oil cooler filter module going into from earlier separate mounts to a combined unit. Then many of the brackets used to have cast iron. Then one phase wherein we moved from cast iron to aluminum brackets. In the latest generation, there is no bracket at all. It's directly mounting onto the engine. So those are pretty much matured in the ICE powertrain. I'm moving on to the electric powertrain. So in the electric powertrain, if you see, one of the major is the battery. Then you have a motor, you have onboard charger.
Right.
The battery is almost majority of the weight. So the battery almost nowadays it is 25% of the vehicle weight, almost depending on the what pack size. So out of the battery, usually the 3/4 is the cell weight. So our starting point is with the cell. What we choose a blade cell which has the highest energy density in the LFP, almost 190 watt hour per kg.
Mhm.
Then you have an option, you go to cell to module, module to pack.
Right.
So instead of going to traditional way, what we did is we have gone to the cell to pack. So there is no module, there is no additional material, the cells going into the pack. So with that, we are able to achieve very high pack level energy density, almost 140, 1.5, which is very highest in this category. That has helped us. That is one thing, cell to pack technology. When it comes to material, the battery, you have multiple options. One is you can go for a steel battery box, or else you can go to aluminum.
Right.
Considering the weight as a prime focus, we have gone with the aluminum. Our entire battery pack newly launched in the electric origin SUVs, BE60 and 90, as a aluminum extrusion, 5000, 6000 series grade of material, which is very high strength. And then we have gone with the extrusion. So that has a really high flexibility to meet the crash requirement at with the optimum weight. So that is one thing has helped us to achieve in the battery pack. Then moving on to the battery enclosures like the top cover, bottom cover. On the bottom cover, if you see, there is a lot of tendency for any stone hitting. So in those areas also, we had a very strong debate. Should we go to steel or should we go to aluminum? So if you go to aluminum, it is a little expensive, but you get weight advantage almost 13, 15 kg. So
Right.
we are going with the aluminum stamping. In fact, G is helping us. Gestamp is helping us in that stampings with a high strength alloy coupled with the laser welding. So this has really helped us to achieve the battery pack much on the lower side. As we move forward, there will be definitely further materials enhancing into the composites or compressed plastic material will help us to further reduce. This is one. One more point I want to touch upon, it's the least focused is the fasteners. If you see in the powertrain, we used to have hundreds of the fasteners. They carry a lot of weight. So when we worked on this electric powertrain, we see a lot of opportunity going for a new generation fasteners. Some of the bonding technologies are available. Then you have the flow drill screw, you have the Rivtech, multiple option. I think what we say is ICE is fully matured. The e-powertrain is evolving, though it is there in the 10 years. But we have to look at many new areas from the BEV, what we can take it back into the ICE is something what we are looking.
Right.
Next is the electric drive unit. So There also we have seen a migration. Earlier, they used to be motor separate housing, gearbox separate unit, inverter separate housing. You connected with the cables. So now what we are using in our latest generation is 3-in-1 combined
Right.
motor EDU. And then there is also integration. Not only just integration, there is also the center housing, which is a single casting for the motor, gearbox, and inverter. You add on only the PC board. So that kind of progress has happened. So
Right.
with this overall, I mean, so on the e-drive level, we are able to get 8 to 10% weight reduction. The battery level with these materials, you can significantly get 15% weight reduction. So those are the areas what we see recently.
Right, right. Wonderful, Mr. Boita. And before I go to Mr. Lahiri, Mr. Johnson, I want to come to you and want to take your thoughts on if you want to add to what Mr. Boita just mentioned, primarily from an EV perspective. If you could give us some more insights into what are the various areas that engineers can tap into when you're looking at reducing weight in the entire electric vehicle, be it the powertrain, be it the chassis, or even the E&E architecture of the vehicle itself. So if you can just delve a little bit more into that.
Yeah, it's a very good question. What I've missed was the opportunity to just introduce Tata Technologies. I work for Tata Technologies. We're an independent engineering and development company. We work for all the major OEMs globally. And so from that, we've gained a lot of experience, and particularly on the development of new platforms for EVs. The platform itself is absolutely key to the business case for a vehicle. Getting the platform right from the start improves the time to market. It optimizes the weight. There's various things around it. So if we sort of take a little bit of focus on the platform, then there's a number of advantages of EVs, particularly the powertrain being very small and compact and not as heavy as a traditional ICE engine. That also allows you to package the vehicle much better, so you can get much more efficiency from the vehicle, which in itself gives you a weight saving. So you'll get a lot more interior room. One of the big advantages and is a clear trend is that what was front engines, front wheel drive has now gone to the back. A lot of EVs are putting the engines in the back. What that does is that frees up crush space, so you can get a very good, efficient crash performance. So things like offset ODBs and some of the full frontals, for example, the narrow offset and the narrow barrier crash in IHSS is very, very tricky. And this allows you to put structure in places that you couldn't before because of the engine. And obviously you haven't got that massive bulk of an engine that takes up the crush space. So that's one of the sort of major advantages of EVs over ICE engines. Just sort of delving into the sort of the lightweighting as well. Obviously, it sort of applies to ICE and EV. As I said earlier, using the various new materials, the steels. And the good point was made on the optimization opportunities. As far as CAE is concerned now, there's a lot more maturity as far as the CAE software is concerned, as far as the material cards that support that software. The predictability of crashing and strength tests is very good. For the last number of programs we've done for Asian companies, we don't do any prototypes now. We go straight into hard tooling because we've got such high confidence, and that can reduce. I mean, traditionally a lead time from a ground up vehicle would have been maybe 4.5 years. Because we've got our own developed platforms, or we work with companies that have developed platforms, and we've now got the less need for prototypes, we can accelerate that down to about 26 months. And we've done that. We've got a product on the road in 26 months. That significantly reduces the investment. It obviously brings much needed revenue into new startup companies, for example. Okay.
Right. And no, very valid point there, Mr. Johnson. And I'll come back to you on that, and talk to you about the infusion of AI as well into that particular domain, and what new possibilities emerged out of that. And I'll come back to you in a bit, and I'll go to Mr. Lahiri. Mr. Lahiri, you've heard the discussion so far, and you've seen the industry is undergoing a rapid change towards newer materials, newer manufacturing methodologies as well. So if I can talk to you about the skill challenge that we are going to see with this, the automotive industry is a very skill oriented and a skill intensive industry. So how do you see the challenge evolving going forward? And from ASDC's perspective, how do you see to sort of circumnavigate this situation?
Yeah, thanks, Mayank, for inviting me to be part of this very interesting discussion. In fact, in lightweighting, there are two major challenges when we look at the skill training requirement per se. Number one is, when everybody has talked about optimization in different dimensions, which necessarily means that the student who is learning this technique will need to be exposed to multiple disciplines within engineering and even outside engineering. When we're talking about cost considerations, we're talking about safety considerations, maybe even ergonomic factors or sustainability areas. So it's kind of very, very multidisciplinary. Unfortunately, in our entire engineering education space, the learning even today is very heavily compartmentalized in terms of various branches of engineering, and very little, cross movements or cross exposure happens to the students in terms of learning the skills from the other domains, essentially. So this is point number one. Point number two is basically that in terms of the curriculum and the activities. So let's say we talk about the conventional materials. If we look at a basic engineering program or a course like strength of materials, or we talk about heat treatment materials, etc., the focus is on repeating what is already being used in the industry. So while that is important, there needs to be a window in the curriculum where there is an opportunity for the students and the faculty material, alternate design, alternate processes, maybe of heat treatment or whatever, the examples that I was talking about. Again, unfortunately, the curriculum flexibility in the system is quite low. So what we at the ASDC are primarily working with the higher education institutions is to plug in short duration elective programs for third year and final year, pre-final year and final year students, in terms of giving them an opportunity or a flavor of what the real life work in the industry is going to be like, where you are trying to kind of work on a particular, not from one dimension, but from various multiple dimensions. And therefore, your skills in digital simulation, use of the software tools. So I think a lot of these simulation software organizations, companies are also working in tandem with higher education institutions, where they're giving access to education version of these softwares to be able, for the students to be able to use this. And more we can use some of these, I think better these students will become prepared to take on the challenge that the industry is trying to solve today.
Right. No, that's a very valid point that you've raised here, Mr. Lahiri. I mean, there really needs to be this multidisciplinary training for the engineering programs that we see in the country. I think today is a world that, even a mechanical engineer needs to be well versed with some of the digital tools and other things, as we see our workspaces and our workplaces evolve with a lot of technology infusion. So thank you, Mr. Lahiri, for making that initial point, and I'll come back to you on this, and I'll go again to Mr. Bhoutkar. Mr. Bhoutkar, again, I want to press you on this particular topic of mega castings. So from Gestamp's perspective, if you can give us a brief idea about how do you see What potential do you see for this technology for the Indian market? Mr. Bhoutkar? Okay. Yeah. Yeah, Mr. Bhoutkar? Okay, I believe there's some network issue at Mr. Bhotkar's end. So in the meantime, till the time he resolves that issue, I'll come back again to you, Mr. Boita. So I mean, you gave us a very good insight into the various ways in which Mahindra has tried to reduce weight in the powertrains. Again, as we move towards these new materials, aluminum and magnesium and even titanium in the powertrains, so there comes a very valid point of an obvious question of the cost challenge. So how do you go about that? How do you go about meeting that cost target that every engineer is always he or she has to really deal with?
Yeah, so I do agree. This is one thing. When you wanted efficient, you need to go for optimum solution. Then that always comes
Right.
with the challenge and the costing. So I'll talk about two things. One is the cost challenge and the different materials. So as I mentioned, one is that aluminum widely we have been using. I don't need to talk about much. In India, I think we have seen very progressed about the die casting, GDC, LPDC. So we have good suppliers and material availability. It's not an issue. I don't see any problem. The magnesium is still a niche market in India. It has got very good potential, 30 to 40% weight you can reduce. The density is lower. You can go for a very low thin wall thickness. But still it has certain challenges related to flammability and corrosion.
Right.
The manufacturing environment need to be taken care. So that's very expensive technology. At the moment, it is, yes, there are few players in India, but I think some more progress has to happen to bring it to a very economic level. That is one thing. And third thing is, as you mentioned, the lot of material we use for the valves, connecting rod, crankshaft, high strength alloys, tungsten alloys, they are still the imported route, not yet developed in India. So that is one area wherein we need to look forward as a country, need to move in this area. So what helping us to control the cost in all of these areas, as John also mentioned, one is the platform standardization. If you see, in that whole globe, many of the big OEMs, world number 1, 2, and 3, they all have more than 30 platforms. What we are seeing, some of the predictions going forward, they're all cutting down on the platform. They're all, majority are coming down to 10, 11 platforms. So that way you're able to do a platform, yet optimize, go for a ultra lightweight optimum solution, efficient solution. You commonize the platform and you get the scale of economics. So that is helping. Yeah. Even we also tried in the recently BEV launched. We have Inglo platform wherein it's a common platform. You would have seen 5 vehicles we have showcased. 2 are launched. So you are still, it is very efficient, but you are able to change the different top heads and have a flexibility. So we need to have that little amount of flexibility, yet go for the optimum weight and technologies. So that is something is playing for us.
Right. I'll take that to Mr. Bhoutkar. Mr. Bhoutkar, you're back now. I hope we can hear you properly now. So, what Mr. Boita just mentioned. Mr. Bhoutkar, can you hear me? Mr. Bhoutkar?
Yeah,
Sorry, I have some problem with the network.
Okay.
Sometimes it's very low, but I think we can go ahead.
Right. Yeah. So what Mr. Boita just mentioned, we were talking about the cost perspective here, and I would want to take your insight into this. I mean, when you move towards lighter materials, obviously, the cost challenge comes up. So, in what ways can the industry really navigate the cost challenge?
That's quite an interesting question. I mean, we've been working very closely with the customers, and the best way is to get engaged in the very early stage, I will say. And the technology, especially the hot stamping technology, when we try to use, its strength should be utilized properly. Like when we are considering the conventional design, which is with, let's say, DP780, DP590, and when we go to hot stamping, we see a considerably increase in the strength, which is almost like 1500 MPa.
Right.
So the design concept needs to be changed, right? And with that change, we have seen and we have many success stories where we see there is a good reduction in the weight, good reduction in the number of part counts, and also reduction in the thickness. The concept defines how you are going to meet the cost, but we need to get early engagement with the customer to define the concept and work and validate it on full vehicle.
Right.
But we see the solutions what we work is really quite cost competitive, and additionally we also come up with our giga stamping solutions where many number of parts are getting integrated with number of functionality getting integrated, like the door ring. If you say we work with one of the customer here in India, and it is now in the implementation phase. So there we integrated A pillar, B pillar, side seal, hinge pillar, and at the end, all these four parts are getting stamped as a single part. So at the end, you are reducing the weight, you are reducing the management of those four suppliers for four different parts. You are reducing the gauge, and at the end, you are helping to increase the safety and integrity of your product, which is really lighter as well as quite cost competitive.
Right. And I'll come back to you, Mr. Bhoutkar, in a bit. I'll go to Mr. Ghosh right now. Mr. Ghosh, on this cost front, I mean, how important is localization of materials? From your perspective, you are offering a range of alternative bonding adhesives and, different variety of materials as well. So, if you can correlate the two things, cost and localization. So what is the roadmap for localization from Sika's perspective?
I will answer. I mean, thank you, Mayank, for asking this question. And I was expecting, because cost is something which is very important. And before I answer to you directly, maybe I will answer, I'll bring one small topic here that when we replace conventional technologies, one of the factor which is asked every day to us that how do you compare the cost with the conventional? So when you talk about, let's say that you talk about welding, you are comparing an adhesive with a electric consumption, which is never comparable. Or when you talk about a bolt or a rivet, it's never comparable. So we encounter this challenge every day. So on one side, we talk about that how do we talk about the total cost of ownership, whether we reduce the weight and it gives advantage on that front, or we let's say we reduce the thickness of a material, and then we can have a better cost optimization, and not just compare that how much is the cost of a rivet versus how much is the cost of a adhesive. This is one side of it when it comes to the cost related to the when we talk about our kind of alternative technologies. The other part which you asked me is it's a combination of two factors. I mean, one side when we talk about is a local production, okay, and I must tell you that local production, particularly in this industry, or probably many more industries, has a lot to link with the R&D function that you have. Because when you talk about composites or you talk about materials, if you cannot have the right R&D to choose the right raw materials, then probably even with a local raw material or local manufacturing footprint, you can still spend more, if you do not have the right R&D. So where Sika has both the advantages. First of all, we are present in all the continents. We have our technology centers in US, Europe, in the APAC. Particularly in APAC, we have multiple locations like India, Japan, and China, and that helps us in evaluating the raw materials and have an optimized formulations done looking at the global requirement. On the other hand, of course, we have a local footprint. We have a local manufacturing footprint where we try to optimize, and we always do the analysis that which makes more sense, whether we should produce everything locally, whether it is making more sense to produce probably where the raw material is there. And this analysis we are constantly doing, and then we bring the solutions localization or domestication where we find it makes more economical sense. But of course, cost is one of the most important parameter, and that's how we try to navigate these challenge.
Right. Mr. Johnston, I'll take that to you. I mean, from an engineer's thought process, I mean, you could have the best innovative idea out there, but you have to really be in the realms of the cost targets. So, what challenges do you see in the current space when you look at the availability of some of these alternative materials that we're discussing about from a local availability point of view?
Yeah, I'll sort of start off by saying that Gestamp and Sika are two companies that we deal with a lot. They're both recognised by myself as real sort of innovation companies that look at lightweighting with the products that they bring along. So as far as, if I take one example, then if we look at adhesives, we've done a number of studies and proven it where you can actually use more structural adhesive, for example, to improve the performance of the body, to improve the torsion and the strength of the body. That results in reduced gauges of the materials, which then overall actually results in a cost saving. So by using more adhesive, you use less materials, less steels or aluminiums, but the overall impact is a cost saving. So that's one example of just what Mr. Ghosh was saying about using the right type of R&D and the right type of technologies. You can actually win-win. You can reduce weight and you can reduce costs. The key, I think, another really good point you hit on there is material availability locally. The stampers leading the way and bringing hot stamping into India, which is a really welcome move, I must say. I spent a lot of time developing the Chinese automotive industry about 15 years ago, and they was in a very similar situation. High strength steels, aluminiums were not available locally, and they strategically moved everything locally. And I think that's key now for India to be able to get these materials produced locally, so we're not carrying the import costs, and then we can become very competitive with those new technologies.
Right. I'll try and go to Mr. Lahiri right now. Mr. Lahiri, can you hear me? Yes.
Yeah, sure.
Yes, Mr. Lahiri. So, you've given us a skills perspective, from a white-collared sense, I mean, the need for multidisciplinary approach in the engineering programs in the country. Now, also, given that we are going to see a change in the entire vehicle construction itself, there will be challenges in the serviceability aspect also, with maybe different body materials, the repairability also needs to change with that. So what sort of skill challenges you see on that front, and what can ASDC do to bridge the skills gap there?
So, in fact, that's a very interesting question because, we are already seeing the impact of that when we've moved from a pure mechanical device to slowly to an electromechanical device, and now with a lot of electronic software going into the vehicle, which in a way is actually also lightweighting the vehicle to a sense, in a way that obviously, a lot of control systems which were very mechanical, heavyweight, are getting replaced by electronic modules, controls, etc. So that itself has caused a very significant challenge on the serviceability of the vehicles, where you want people. So while we we do have our share of struggle on the mechanical side of things, but I think that's pretty decently sorted, and we are able to plug that gap very significantly. The challenge comes the moment it moves to the electronics, the software elements to it. And now when you add to it, new manufacturing processes where, let's say, a certain amount of sub-assembly is replaced by a single piece because one could possibly do it with a 3D printing, and therefore, what do you do with the repairability of that, or how do you do the replacement of that, will entail a whole new, effort on the part of the entire industry to be able to upskill the existing service technicians, and at the same time also focus on the new blue collar workers that are getting into the service segment as to how they need to be trained, what are the kind of exposures that they will need to be given in order to be able to maintain the vehicle in the right condition. Today we see that as a great challenge, even when the software component of the vehicle is increasing substantially. So understanding the diagnosis, understanding the replacement, and also meeting the customer expectation, because customer in a mechanical world was like they needed a quick fix. But today the vehicle goes in 15 minutes, it has to be kind of done. But if it's a software and it takes a while in terms of upgrading the system, etc., then obviously it has a whole lot of customer expectation challenges.
Absolutely. Absolutely. No, thanks for that input, Mr. Lahiri. I'll come back to you in a bit. I know you have to go in a meeting at the ministry. Just bear with me for a few more minutes, and then I'll let you know.
Sure.
And Mr. Johnson, if I can, take that software angle to you, and like I was talking to you earlier, that this AI infusion coming into the simulation space or the software space right now. I mean, how do you see engineers leveraging AI when you look at design from a lightweighting perspective itself?
Yeah, I think the AI for me in the design stage of the vehicle, if we look at that, it's primarily my focus will be on what we call design rules. We try to standardize the design processes that you get. When I say we, all OEMs, everybody does it. We'll have standard design rules for certain conditions of certain areas of the vehicle, for example. It's how we can accelerate the automation of AI with those design rules and then speed up the design. That's the challenge for me. There will be a level of AI feeding into the CAE that we talked about earlier. I'll be honest, I'm not a CAE expert. I work with the CAE experts all the while, and I've seen the fast improvements without AI into CAE. So I can only expect that the predictability, particularly as we go into new materials, because that's always the challenge with CAE, is when you get a new material, we need to go through a testing process. We need to do things like drop tests, dynamic tests to be able to get the curves correct on the CAE. That's where I see AI will hopefully accelerate the confidence in the predictability of new materials in particular. So between the CAE and the design improvements, again, we should be looking to, I'll keep going back to it, to try and reduce the development time, because that's key. The quicker you can get a new vehicle on the road, and obviously it's got to be lightweight, safe. They're all givens now. They're absolute must-haves. There's no no choice, and obviously cost as well. The three sort of key areas. If you can the quicker you can reduce the time and get the vehicles on the road, then that will be the focus, and that's where AI will give the biggest contribution, I hope.
Right. No, absolutely. I think time to market is absolutely crucial. And Mr. Boita, I mean, would you want to add to that what Mr. Johnson just mentioned around the use of artificial intelligence in CAE, in design, your thoughts from an engineer's perspective, and like Mr. Johnson just mentioned, time to market. And I think what better example than the two Mahindra latest BEVs, the XCV 9e and the BE6. I think you have really shattered all sort of benchmarks in terms of, putting those two products out in the market in really record time. So your thoughts, from as an engineer, how do you see this technology foray really helping in reducing the time to market?
Yeah, Mayank, sure. So definitely the AI, I mean, it's a very big and game-changing tool actually, and it is already penetrated. Actually, I would not say it is now upcoming. It's already has been penetrated across. So a lot of areas we use AI. For example, in the engineering, in the battery area, we use a lot of AI-based algorithm for the field monitoring, predictions. Those area,
Right.
one thing we use it, and and doing a lot of design of experiments. It is helping. For example, in a battery pack, when you want to do a cooling plate design, so there are infinity options possible. So you have certain targets when you want to do. If you use in the past, when we used to do 30, 40 loops of simulations, 1D, then 3D, CFD, and go back. So all this can be integrated with an AI with the targets what we're looking. So within a short time, you're able to get, and AI is giving you very high level, quick, optimized solution. Then you take it to the detailing it. So
Right.
extensively being used in that, in the CE simulations and a lot of design areas we are using. So it's a really great tool going forward. It will come into much more way.
Right,
Yeah.
right, right. Mr. Lahiri, if I can come to you and get your thoughts also on this particular topic of AI, and you spoke on SDVs and how that is going to shape the future of the automotive industry, but also AI, AI as well as automation. I mean, the general notion is that that is going to be impacting a lot of jobs in the sector. But from your perspective, how do you see the impact of AI coming? And how do you see the impact of this particular technology in the overall automotive ecosystem?
Yeah, surely I think AI is going to play a big role in everything that we do in today's world, and how it will shape it in the future. And as far as AI in this whole design process itself is considered, I would say that a lot of routine work, the speed with which you can turn around new designs, do testing, stimulate, etc., is going to kind of also get very heavily impacted. So when going back to my earlier point about multidisciplinary area, AI will become like a very underlying principle. So it's personally, I see AI application today more like what we had, the computerization in the 80s and 90s, kind of a thing. And as probably even hardware becomes even even more conducive to AI applications as we go forward, the chips become faster, the processors become much more reliable, etc.
Right.
So I think it's going to have a huge impact. Therefore, even on the diagnosis side of the vehicle, on the after service, I would say, a lot of it can be AI enabled or supported. Today, a lot of troubleshooting kind of depends on the skill of the technician
Right.
to go step by step in terms of figuring out what is wrong with the vehicle and what needs to be fixed, etc. However, if there, and I'm sure people are already working on this AI application to kind of through machine learning allow platforms to do a lot of machine-based troubleshooting or self-troubleshooting in the vehicle, which actually comes up with a solution, and then you just go and fix that solution.
Right.
You don't really not even need to do diagnosis. In fact, that's one of the areas where a lot of technician skills comes in the traditional way in terms of diagnosis. So I think this has a very large implication going forward. In terms of number of jobs, I would disagree that the number of jobs is going to go away. It's going to go away in some areas, but it's going to be much more in many other new areas, which we today don't see people working on. So probably a lot more people on analytics and stuff like that. It's the same thing which I think we had a fear when we were growing up. Computers will eat away all our jobs. But actually, what has happened is computers have enabled so many different jobs. And I think with AI as well, it will be like that.
Right, absolutely. And just before I let you go, Mr. Lahiri, I know you have to just run into a meeting at 4 o'clock. Just a quick sense of the policy push around skill development. Whatever you discussed throughout this conversation, how does policy come into the entire scheme of things, and what is the push that is expected from that front, so that you are creating a future ready industry workforce.
Yeah, so I think in terms of policy, we've made very significant improvement over the last couple of years. Becoming much more flexible, the frameworks becoming much more integrated. So today we have a national credit framework policy, which essentially allows seamless integration between education and skills, which used to be two very different verticals, and that kind of has gone away, or going away. I would say not gone away; it's a work in process. So on a policy side, I think the focus is on flexibility, collaboration, and integration of the various arms of skills, training, education, lifelong learning.
Right.
How do you integrate all of that and provide a very seamless experience to the learner over his entire life cycle of learning? And that we do see even in AI policy, for instance, AI education policy that we are looking at. And I did a chapter on that in terms of automotive application, where we are talking about AI for all, which means that everybody needs to know a certain level of AI. Then AI for many, which means that there will be a lot of specialized knowledge will many people will need to know, not all, but many people. And then AI for few, which is very specialized part of AI application development, etc., which might be with a few or a relatively lower number of people who need to be trained on that. So
Right.
this kind of a segmentation and a focus, I think, is going to be very useful in the long term in terms of the Indian ecosystem. And working closely with the industry, I think this will make it work very well on the ground.
Right, right. Mr. Lahiri, thank you so much. Always a pleasure talking to you. Really appreciate you giving us these enriching comments. Really pleasure.
Thank you. Thank you, and my apologies for a last-minute change, which was not beyond my control.
Not at all. Thank you so much. Always a pleasure, Mr. Lahiri. Thank you so much. Thank you. Mr. Johnston, if I can just take that element which Mr. Lahiri just mentioned, integration and collaboration. So in this entire scheme of things, when you see a huge transformation underway, how important is a collaborative approach, maybe between an OEM and a technology player like you? How do you see the role of collaboration going forward?
It's huge. I think it's something that the industry has evolved into over the last few decades. Once upon a time, a car company and OEM would melt their own steel and make their own parts, and it'd be from cradle to grave. Basically, they'd do the whole thing. What's evolved over the last sort of that's probably 50 years, but particularly in the last 20 years, is this collaboration of specialist suppliers. There's companies like us which do the design engineering. We'll work with people like Sika, Gestamp, universities as well. If we talk about innovation, then often we'll work with universities and key suppliers to ensure that we bring in innovation. And innovation is an interesting topic because it's innovation to a company may not always be innovation to the rest of the world, as to speak. So a new type of technique, for example, just something like a sliding door that some companies may never have worked on a sliding door before. That's an innovation to them if it's the first time they've produced it. So the techniques and the way that you bring in an innovation is very key. And a part of that key is working with companies like ourselves, where we've got the engineering experience, but also key door suppliers as well, who have that type of experience as well. A sunroof and a convertible roof is another good example. There's a number of key specialist suppliers out there that we'll work with because they've got the decades of experience learning that you can't pick up. As you just mentioned a minute ago, maybe with AI that learning can be incorporated into automation and very quickly improved. But I think there's a very interesting point made as well that about will we lose jobs as AI moves forward. I think if we look back over the past, again, 50 years, going back to a non-digital engineering stage, there was a lot more manual type work being done. That transferred to more digital type work. So CAD, CAE, as we mentioned earlier, a lot of the sort of what was manual become electronic, and it employed a great number of people supporting that. And I suspect that the comments made earlier about AI will be exactly the same, that there'll be different types of skill sets required to use the AI as well.
Right. And before I take that point to Mr. Ghosh, I want to come back to you, Mr. Bhoutkar. We left upon a topic. There was a network issue, and I wanted your perspective on giga castings and its potential for the Indian market. How do you see that playing a big role going forward? Because it's a key technology which is evolving, and you've already seen a lot of application happening elsewhere in the world. Although you've given us some insight on that, my question really is, do you see that remaining limited only to the premium end of the vehicle market right now?
We do see that the giga casting is very high capex intensive product. That is first thing, yeah. And on the other side, for Indian market, we see aluminium is another big cost negative topic, yeah. So mostly the Indian companies, as we see, are right now exploring the other alternate lightweighting solutions. And with respect to that, we are innovating certain solutions like our giga stamping solutions. And that could be a good counter to the giga casting as well, yeah.
Okay, right. Mr. Ghosh, coming to you, I also want to touch upon this element of circularity. Now, with these newer materials coming in, and especially in your case, the materials that you offer. So, how do you see them from a sustainability point of view as well?
Mayank, this is one of the most important topic probably you touched on, particularly when the use of chemicals in the automotive industry has been increasing. So when you talk from a perspective, we work on three different perspectives, you can say. First thing is that to measure from the cradle to the grave, and how do we have these from the ESG point of view, and what we do is also the EPDs. So from the sourcing point of view, that we talk about from the sustainability. The second part is about the use of the recycled raw material. For example, like we use plastic components for the reinforcer and the baffle parts. And we try reinforcer. We developed raw material sources which are recycled. And the other part are these. For example, we use epoxies as a structural adhesives, and reinforcers, etc., where we use epoxy, and we develop raw materials with a bio-based raw material. And so when you talk from this perspective, this is an important area, and we are also working when it comes to the vehicle recycling level, how to separate these kind of adhesives and chemicals used in the vehicle at the time of recycling. And when you talk from that, we are also talking about that how can you separate them, what kind of technologies. And Sika is very committed to the sustainability, and we have our own declared as part of our strategy. We have our declared net zero CO2 commitment, and most importantly is that we work very closely with our customers in enabling them to meet their own CO2 and the net zero commitment. And one of the goal is also that we developed is like the low bake products, like the structural adhesives which are used, or the reinforcers, or the injection molded baffles. These are the traditional products are designed with baking conditions of the current the current paint shop, which is, let's say, about 160 degree, 180 degree approximately. But we are now developing products, and we have products actually which are developed already for to suit the requirement where you can reduce the temperature of the baking oven to 130, 140 degree. And of course, as and when the whole universe of paint and the pretreatment chemicals and the CAD, all these, when it develops, we are also working that how can we bring down further the baking conditions. And this helps also in the automotive companies and the tiers to reduce their the oven temperature, and of course reduce the CO2 footprint.
Right, right. Mr. Boita, I'll take that to you. I mean, from a powertrain perspective, and we are going to look at, regulations like RDE, WLTP, and then eventually BS7 come in. So, from that point of view, how do you see, I mean, if you can just shed us some light on, some major trends in the powertrain side that we're going to see towards efficiency enhancement, and a lot of them could be towards, reducing the weight of the powertrain itself to meet these more stringent emission norms that are going to come in near future.
Yeah. So thanks, Mayank. That's a good good question. Yeah. Before that, I'll also add on to the Debanjan Ghosh, like the CO2 and regulation circularity. This is becoming one of the major parameters. Earlier in the design criteria, you have the weight, you have the cost, you have the serviceability, you have the XX. Now, in all these design feature selection, when you want to select any architecture, now there are two more things are added: the total CO2, recyclability. So this is very important. We promote all our engineers. When you make any choice, any component design, please add these two into the parameter. Even I can see in some of the European consultant, I see these two. When you choose a battery housing, you have an aluminum, you have a plastic, you have steel. So there is a CO2, there is a recyclability is coming as one of the main parameter we need to ensure. So yeah, that's what I want to add it to Ghosh. And also I want to, since Sika is there, so I also want to give a request also. On these, there are many new techniques, the the bonding techniques. Instead of fastening techniques, we can very well use it. We also wanted certain debonding techniques also. Some of the cases, we do get a lot of optimization when you go for a bonding techniques, but we also need something debonding when we need situation something. So I know there are a lot of work is happening, but I wanted this to come to quickly to the SOP, and then we can use much more bonding techniques. That is one request. Moving on to the efficiency and weight, they are pretty much very clear. It has been in the past when you moved from CAFE 1 to CAFE 2, CO2 norms are getting stringent and stringent. Of course, at the end, we are helping the earth and future generation. It is required to do that. So to meet the CO2 requirement, the weight is one biggest criteria. When the vehicle weight goes up, then your powertrain weight also will goes up. Cyclic effect, when the powertrain goes up, then you will have intake, exhaust mount, all this adds up, then drivetrain losses will increase, then cost down will increase. It is a cycling effect. So for me, the weight is a very, very most critical parameter we need to control as we move forward, whether it's ICE or EV powertrain. As you're moving in the Europe, the CO2 regulations have stringently has come down earlier, 95 gram, then further is 71 gram. As we move forward, there's also new regulation going to come, utility factor, what we're going to use even in plug-in hybrid or range extenders. They are all going to help based on the range what you get. If you want to get a higher range, you need to have low weight. Weight is directly correlating to the range. So one is you want to reduce the vehicle weight so that you can go for a optimum size of the battery, and it helps in the efficiency. Many of the component can work at a higher efficient manner. So this is helping you to meet those emission norms. Now looking forward, now what we are seeing is right now we are already BS 6.2 is done. Then we have done CAFE 2. Several technologies are implemented. Now what is coming up in the going forward is BS7 is in discussion, and Euro 7 a little bit not as stringent as originally Europe has showcased. Now slightly it is less, but that's coming up. And India government also looking. There's a new draft is in discussion today, so it is expected to come down the line. And then there will maybe also follow up of the CAFE 3 norms, wherein again you need to look how can you optimize and reduce the total CO2. This is one way is coming. So definitely, I think this is one of the session which I liked it very much, because this helps for the total CO2 reduction also. When you try to optimize the weight, indirectly you are helping to reduce the total footprint of the CO2. So I'm looking forward.
Right, right. Just one more comment from you, Mr. Boita. Although it was very evident when you made the request to Mr. Ghosh, about the collaborative efforts that we are seeing in the industry. But just from your perspective, how do you see the importance of such concurrent engineering or maybe collaborative approach going forward? As we see, I mean, the time to market is very crucial. You have to be very optimal, you have to be very optimized and frugal in terms of your spendings as well. So how do you see the role of collaboration in the industry going forward?
Yeah, it's highly required. In fact, when you want to go for ultra optimized efficient, you need to collaborate with the different interfaces, not only within your system. How can you collaborate with the other system? It could be supplier, it could be different interface, it could be vehicle, it could be, there can be multiple solutions when you interact and have a different interface systems collaborate. So there are multiple avenues. So that way, I think one is the Sika is there, so I can talk about it. We also did mention. So when we want to use a lot of bonding or thermal conductivity materials, you always have a comfort zone, what thickness you want to use it to take care of all our manufacturing variation. We can leave it like that and have a higher thickness and take care of all the production component variation. Then you have a higher weight and higher cost. Or you work to collaborate with the partner like Sika or somebody, and then you try to find a most optimum solution. How
Right.
can you optimize your component to bring it to acceptable tolerance level? Then how can we use the optimum thickness for thermal conduction or bonding strength or whatever? So this is one way we can see that. And also into the, and on the other side, Gestamp is there where we closely work actually. How can we use aluminum stamping
Right.
battery? So initially, in fact, I thought it's quite easy. Aluminum stamping, steel stampings are much critical. When we started using aluminum stamping, I could see how critical it is. So the oiled material is so important to have a forming without any cracks. So that we
Right.
have learned. So that really calls for a collaboration with the partner and then fine tune the design aspect to use effectively the manufacturability. Uh, so as an OEM, we may not be knowing everything, and supplier has a lot of experience. We need to bring those expertise into our system and fine tune to make a win-win situation. So that's very much we can see. And also I have a request for the G stamp. So one is the aluminum stamp we are using. Then in the vehicle we are using hot roll stamping. There is also the roll forming technology which is there in some part of globe, which also I feel we should bring it to India, roll forming, so that we can use much more thinner cross sections and form in a way you want to meet the crash requirement, and then make a, it could be the battery pack housings in a roll forming, or a BAW seal sections you can do in roll forming. So that is one area where there is a good potential for the lightweighting.
Definitely, definitely, Dhananjay. We are in discussion with you, I will say, already on this topic. The thing is, we need to, when you are designing the vehicle in the starting itself, you have to select the manufacturing technology. Otherwise, in later stage, designer would not want to do any design changes. That is one important thing. And globally, we are doing, advanced high strength, ultra high strength, even Martensite 1500 we are doing for rocker and seat cross member. So that is not really a concern to bring that technology to India. We are ready to do that. But we need to see that the OEMs are designing the vehicles considering the availability of that particular technology, then it becomes a very viable business case to bring certain technology.
Yeah, I agree. Yes, we need to collaborate and
Right.
deliver the
And
best.
since we are on the topic of collaboration, Mr. Bhoutkar, your thoughts, I mean, with this kind of evolution in both materials as well as manufacturing processes, I mean, does an OEM need to sacrifice on some of the design elements that they might have in their components, or as a tier one supplier, you're ready to, I mean, bring out the innovations and cater to what the OEM requirements really are? I mean, what are the challenges around this space, and how are you able to mitigate them? Mr. Bhoutkar? Okay, I believe there's some problem.
Sorry,
Yeah.
sorry, Mayank, sorry,
Can you hear me?
sorry, I had some network issue again, but can you please repeat the question again?
Yes, yes. So I was saying that since we are on the topic of collaboration, so is there some sacrifice that an OEM must make in terms of the design of their components when they're looking at newer methodologies like hot stamping or newer materials like AHSS, UHSS? I mean, what are the challenges here, and how, as Gestamp, as a leading tier one, how do you plan to mitigate those challenges? Mr. Bhoutkar? Okay, I believe there's some network glitch. Mr. Johnston, would you want to take up that question?
Yeah, I was going to offer
Yeah.
because of this. Yeah, working with Gestamp and obviously with these new high strength materials, the formability is the biggest challenge as far as particularly dual phase and up to sort of 1,000 megapascals, where you're cold pressing the issues. So this again is where predictability comes in, and CAE stamping CAE in this case, that we need accurate CAE support or sorry, predictability to be able to understand what sort of shapes, what sort of forms we can get into these high strength steels.
Right.
I think I always give an example when I first started working with dual phase about 15, 20 years, well, no, about 25 years ago. I was so used to being out of in a production line, you could go and rework panels. If you hit the dual phase with a hammer, the header most probably fall off. It's that hard. It's and then there's another. So formability joining processes are challenges that we need to address when we work with these new materials, and especially if we talk multi-material, if we start talking about composites as well. But sorry, I've just lost my train of thought there. The sort of the challenge, I guess, as well is designing the part to suit the technology. So if we understand that it's a difficult part to form, then we make the design as simple as possible, but take on board the benefits of those materials and use the design to suit.
Right. Mr. Bhoutkar, are you able to hear me now?
Yes, sorry again. I think it is maybe because of rains, no? The network is really getting down sometimes.
Okay,
Yes.
okay, I understand. No,
Yeah.
I mean, just, we were talking about some of these formability challenges with the advanced materials, like Mr. Johnson just explained, with AHSS and UHSS, you see some formability challenges. So as a tier one, how do you mitigate some of those issues when a design comes to you from an OEM?
I think this formability is really not a very new topic to us, I will say. We've been doing this from almost like 25 years, especially with this hot stamping material, not just that, but also the roll forming simulation we do with Cobra as well as with I personally used to do with LS Dyna as well. So we have that know-how in-house, and we know how to tackle those formability topic and uh, doing the code designing, which was again your previous question, which unfortunately I couldn't connect on. But code designing is something what we do with the customer, and then the code development, which is very critical because uh, some of the customers or OEMs right now, they are not really exposed to the technology and its limitations, what they have right now. So we need to, have a very in-depth co-designing and co-development with them from the very early stage. Yeah.
Right. Mr. Boita, your thoughts on that? I mean, do you see yourself in a situation wherein, there is a conflict? I mean, you would have designed some part and, I mean, there could be issues at the manufacturability end. So, what is the middle way after that?
Yeah, I mean, it's very pretty much common. Do have such an issues in the design phase, not once the tool is made, we have faced such an issue, except exception one or two.
Right.
So definitely we have seen suppliers, for example, G, in the design phase, we used to provide them the design, then G used to review and then give initial pre-engineering. A lot of work happens, then they
Right.
give the feedback, then you modify, and then they do simulation. Sometimes there's always a different requirements. We wanted to meet certain requirements, whereas other side you might have different challenge in manufacturing. Then it is better to dwell in the design phase rather than once you go into the die and made the tool, then it's much more challenging. So we always debate, discuss, and then try to find an alternate solution. It happened in many cases, the design what we released the first S4, what is the final tooling kickoff stage is not many changes happen, but that is required as a part of design. So we need to collaborate, understand each other requirement, and then try to find a win-win solution. So it does happen. So it's very common, and then every supplier it happens.
Right,
Yeah.
right. We're almost at the fag end of the discussion, and I would now try and take some of the questions coming in from the audience's side. And
Mayank, maybe just if you can give me 10 seconds to reply to Mr. Boita,
yes, please.
because I do not want to interrupt in between. So just quickly to tell that thank you for bringing the topic of debonding. And it's also part of these recyclability it's also very important part. So we are constantly working on it. It's always about a part about it's kind of a magic sauce that we sometimes talk about, that we want to have the best bonding when it is working, and then it should just come out at the end of the life cycle. And that's not always very easy, but we are working on multiple solutions and technologies on it, and we have developed multiple things. One of the example, for example, is the thermal conductive gap filler used in the batteries. And that is something which we have developed already, products which can be debonded very easily. And so we have the solutions already, and we will like to discuss more with the OEMs about the areas that they find it more relevant, and where they do not see it that much relevant. But this is a topic which is very active in Sika. This much I can assure you. And our team, a part of our R&D team, is constantly working on developing the technologies which they can use for the debonding. So,
Great. So not only at the end of the life, even during the operation also, we wanted to serviceable debonding. So yes, we will discuss.
No, great. I think it's lovely to see a glimpse of the
Collaboration
approach in the industry, and I think that's the way forward. If you want to develop products in the most frugal and the most time-effective manner as well. I mean, I'll just switch to taking a few questions from the audience, and the first one I can see from Mr. Nikhil Deo. This is addressed to you, Mr. Bhoutkar. So, what is the play for high strength cast aluminum alloys for structural parts in the vehicle BIW? What is the opportunity for such alloys?
I will say John can take up this question, but I really don't see it will be only in some of the area on the suspension side, I will say. But from BIW side, I don't see enough opportunities, I would say.
Okay.
Knuckles, they use knuckle suspension parts they use.
Yeah.
Okay. Right. The other question that has come up is from Mr. Suman. What are the challenges in aluminium stamping at the time of manufacturing?
There are many challenges. Yeah. We do see like if the variations in the RM side, when there are big variations and not defined as it was supposed to be, then the formability result and your real tryout results are going to be very different. On the other side, we see this is very flexible material. So again, the spring back is also one of the very concerned area if the thickness is really low.
Okay. I'll take the next question, which is coming from Mr. Ajay Sinha, and I'll open this to all of you. I mean, you can just, whoever wants to take it up. What is the role of magnesium in the Indian industry right now?
I
Yeah,
think
I
we
can add.
can, yeah, please, Dhananjaya Rao. Yeah, please.
Yeah, so definitely we see magnesium coming up very heavily into the clutch housings, transmission housings, very low wall thickness, like 2 millimeter, less than that also even possible. And almost the strength is very similar. Density is much lower by almost 1/3. Then that helps us to achieve low weight. Right now, some of the high performance car engine blocks even used in the magnesium, not into the mass market right now for the cylinder blocks, but there is a lot of development work is happening. Everybody is interested. And some of the even high performance vehicle body chassis also even made in magnesium. In the automotive area, this is something every OEM I'm sure working on these magnesium alloys for multiple parts. Pretty much easy to do in oil sums, front covers, housings. So block IC it might take some more time. Yeah, some of the challenges are, as I mentioned, the manufacturing process needs a very special environment, need to be controlled environment when they do the casting. So that need to be taken care. That needs a lot of capex and process control.
Right.
So that is a challenge to come in a big way. But yes, it is definitely evolving in India.
Right, right. I'll take another question. John, I think you'll be the better person to answer this. Do you see any collaborative efforts happening to generate data for new materials and processes that can be used for CAE by all? I mean, you can have a consortium maybe wherein this data can then be circulated for everyone's perusal.
Yeah, maybe I can give a bit of an example. A number of years ago, we dealt with a company which developed HFQ, so hot form quenched aluminium, and that was a collaboration between a new startup company based in London and one of the universities in London as well, and then ourselves. And we developed helped develop the technique along with that. There was another companies as well that used it. And from that become a supplier. So and then there's many examples you can look at where, as I say, innovative and new technologies are developed by not just by one company. There's an input for everyone. So we obviously, being a part of the Tata family, we work with Tata Steel, and obviously we're always looking to help them when they're looking at new materials. We need to understand the design requirements, how best that material might fit into a design requirement. You mentioned earlier about high pressure die castings earlier. So there's been a lot of adoption in premium cars on those where they can reduce the number of parts. And that's a marriage between an engineering company or an OEM, an engineering company like ourselves, and a supplier to get technologies to work to the best possible. So, another good example is we developed the Polestar 1, which was a steel platform. It was the Volvo steel platform, and it was a carbon fiber top hat.
Okay.
An incredibly innovative solution, and there was lots and lots of learning when we used various companies, including companies like Sika, to look at the bonding, how we would join the two technologies together, the steel platform and the composite top hat, and then a lot of CAE innovation as well, because the material cards and the use of those material cards were not familiar to companies like Volvo. They were used in low volume niche companies where they wouldn't have the same sort of database. So the database needed to be developed. And it links a little bit to one of your questions from the audience. I noticed they said, do we have records, design records and design what was it, experimental records? Yes, yeah. Well, as I mentioned earlier, we do. We have design guidelines which are developed from issues we've learned in the past where we've had issues in, either in CAE or in engineering or in prototype builds even, and then we've recorded those issues, and the key, then the key step then is put it automation. So we don't just take a record and keep it in the old days like a design guideline. So it'd be a PowerPoint, for example, with illustrations and records. It actually goes into the CAD model, and the CAD model will now have automation. Will have scripts where that we will design so for example, a door shut will have pass-by clearances, it will have standard gaps, etc. That would all be a part of the design records that we keep.
Right. And in fact, the next question is very interesting, and it's, it talks about carbon fiber. Sorry. From Mr. Nirjar, and he wants to understand, how do you see carbon fiber helping in lightweighting on a larger scale, and what are the ideas for cost optimization when you talk about carbon fiber?
Would you like me to answer that, or
John or Mr. Boita? I mean,
sorry.
who wants to take it up?
I'll go first, Mr. Boita,
Sure.
if you finish. I've been to conferences about 20 years ago where the next big answer was carbon fiber, and it's never come into the main play. BMW used it for a little while. I think it was on the 7 Series and the 5 Series, and they seem to have gone away from it. Carbon fiber itself is a hugely expensive base material. There are other composites that are better from my point of view. It's only certainly, whilst it's at this expense, it will only ever be niche vehicles that will use carbon fiber. I don't see it personally coming into the mass market because of the cost, but other composites are here already. Mr. Boita?
Yeah, I fully agree. I think you added. So I mean, it has got great strength and ultra lightweight is possible, but it's very high energy capital investment. So costs are right now not at the moment in a mass market affordable. Yeah.
Yeah, agree.
Right. And
instead of that one, what I can see is these compressed molded parts. They are getting more traction, especially in the powertrain. Some of the large enclosures, even up to a 2-meter size of enclosures, they are getting compressed molded. So they do have pretty high strength, and then it's upcoming.
Right. I'll take the last question here, and I think Mr. Boita, I think you would be able to answer this better. Can recycled materials be used for car upper body structures? Is it feasible in terms of cost and performance as well? Mr. Boita or John, I mean, whoever wants to take this.
Yeah, I think I would suggest John take
Sure.
it. Then maybe I can add a few points on the.
Yes.
Yeah, I mean, most when we talk about recycled materials, most vehicles now use a lot of recycled materials. Certainly plastics and polymers and so on, but also steel is highly recyclable, and aluminium. There's a lot of companies which do closed cycle recycling. The grades of aluminium, I'm not a material expert, but the grades of aluminium that can be recycled or come from recycling are limited. You can't necessarily use, I'll give an example, I'm pretty sure you can't use aluminium skin panels from a recycled material, but there are, Jaguar Land Rover and a number of other people are using in-house recycled aluminium within the products already. And as I said, steel is highly recyclable as well now.
Right. Mr. Bhoutkar, would you want to add anything to that?
Sorry?
There's this question around the use of recycled materials for vehicle upper body structures. So is it feasible in terms of cost and performance?
I think it should be feasible, no? I mean, recycling is just a process of getting the same input which is required finally to make certain part for certain functionality. So it shouldn't be an issue.
Right. And with that, gentlemen, I am afraid we have completely run out of time, but I really appreciate all of your comments throughout the panel discussion. I think it was a very insightful discussion and enriched by all of your comments and around the new materials, the new technologies in terms of manufacturing, in terms of design, in terms of the use of things like AI coming into the picture as well. So thank you so much. I really hope all our audience members have a lot of takeaways from this discussion. And I look forward to seeing you again sometime in the future, and really appreciate all of you joining. Thank you so much for taking all the time.
Thank you very much.
Thank
That's
you.
great.
Thank you,
very
Mayank.
much.
Thank you, Mayank.
Thank you, everyone.
Yeah, thank you, everybody.
Bye.
Thank you
Really
all.
interesting. Bye-bye.
Thank you all. Bye.
Thank you. And with that, we move to the next session, which is a fireside chat with Mr. Amit Jain, who is the Group CTO of Uno Minda. Uno Minda is a leading tier one supplier in India, which is supplying a range of parts, right, from switches to seats to lights, and now venturing into a lot of auto electronic technologies as well. Mr. Jain, thank you so much for joining us here today and taking the time out to speak to us. Mr. Jain, I think there's some audio issue. We are unable to hear you.
Are you able to hear me now?
Yes, loud and clear, Mr. Jain. Pleasure to have you with us. Really appreciate you coming over.
Likewise, and great being here. Yeah.
Yeah. So I'm sure you would have listened in to the conversations earlier, and the broad theme of this event is lightweighting and how that is becoming a key driver towards efficient and more sustainable vehicles of the future. So your broad thoughts on that, Mr. Jain. How do you see lightweighting as an engineering methodology playing a key role in the automotive space right now?
I think lightweighting is, very integral to automotives, right? I mean, right from fuel efficiency and now gaining more and more importance with the whole part of electrification.
Right.
And it's no longer just, I would say, light, but light and smart. Are both very integral now to the whole uh, the new automotive era, let's say. So I think in everything that we do, it's be it an electronic design or be it the usage of software,
Right.
new tools. I think lightweighting is a common theme that run across as a horizontal.
Right, right. And if you can, touch upon some of the key methodologies, Mr. Jain, that you're deploying in terms of, reducing weight in the components that Uno Minda has an expertise in.
Yeah, so I think several of our products, I mean, we are into something like 28 different product segments, be it two-wheelers or four-wheelers, right from seats to alloy wheels to electronics,
Right,
anywhere that we can save weight, is always appreciated by OEM. So
right.
we take it very seriously. So there are obviously, larger parts, body and structural parts that we do, things like seating and lamps, and in these or alloy wheels. I think in these cases, what we are primarily working on is usage of alternate materials, moving to say alloys, special alloys, which are lighter in weight, like magnesium and others for our wheels. We're also working on using lightweighting seating mechanisms, which go into right from large buses to cars, and how we can reduce weight there. Plus, even in electronics, what we're seeing is there are a lot of new manufacturing processes
Okay.
that can be used in order to, say, for example, like reduce the amount of, say, epoxy or potting that is used in for thermal and other things. Plus, also, we make certain products which are specifically targeted towards lightweighting, things like say blow molded parts, which
Right.
act as energy absorption and also reduce a lot of weight when compared to other metal, as well as say injection molding processes. So
Right.
yeah, we across nearly all our product segments, we have we have a roadmap which is very focused on lightweighting. So there's a product roadmap, there's technology roadmap, and lightweighting is one of the themes that these are always looked upon. Yeah.
Right. Mr. Jan, when you say you have a roadmap which is outlined, for the future, So is there
Mhm.
also a target that you have set for each of these product categories, in terms of if you can quantify that in terms of the percentage weight reduction that you would want to achieve over a certain period of time in the future?
I think these are very closely coordinated with the OEMs. Yes, we do have say so everything has a cost and price point to it, right? So
Right.
I can reduce weight by 30%, but if it comes at 200% cost increase, then obviously that is something that the OEM may not want to take on. So we
Right.
have these regular conversations
Right.
with OEMs where we look at how important it is for that particular vehicle segment. A few of our products get very targeted towards say high efficient vehicles. Say for example, we are working on lightings in the US for a fully autonomous shuttle, where it's an electric autonomous shuttle, and their weight is very, very critical. And
Right.
we do, and and cost may not be the primary aspect. And there we are able to take targets that are much higher when
Right.
compared to maybe a high volume two-wheeler in India. Yeah.
Right. Right. So when you look at, the Indian market, which obviously is more cost sensitive, Mr. Jain, so, what are the key enablers that you see of lightweighting? Like if you have to deploy, lightweighting in a particular component, what approach would you rather take, to achieve the right balance between achieving the weight reduction as well as not taking the cost increment way too high?
And that is, I think that's a great question, and that's where innovation comes in. So
Mm-hmm.
if you look at innovation not just from the usage of new age materials, yeah, but also look at it from a perspective of manufacturing processes. So there are now new manufacturing processes that can enable you to, you know, I would say, uh, redefine the way a certain product is designed. To
Right.
give you an example, say for example, you're making an ECU for a two-wheeler, and
Right.
because it is exposed to the environment, so you do a lot of IP
Correct.
protection that
Yes.
it and from a vibration, water seepage, from all those perspective. But say if I use a new manufacturing process like which has also been there around, but say low pressure injection molding that can
Mhm.
uh, that can completely eliminate the use of heavy epoxy material and also reduce cost. Yeah, so it's a new age process, can be used for electronics, can give you a cost reduction, and at the same time can give you a weight reduction. So
Right.
these or so a few of these innovations we focus on quite a bit, right? And
Right.
right from say handlebars of two-wheeler,
Mm-hmm.
even using a new age material or filling a pipe with a certain foaming material, you
Mm-hmm.
can improve structural rigidity and still reduce the weight of these parts and improve their say their vibration
Right.
resistance. So there's a lot of innovation that goes into this, and
Mm-hmm.
it's a combination of material science, combination of usage of new CAE techniques,
Mm-hmm.
and at the same time of new manufacturing processes.
Right, right. No, I mean, there are some very interesting examples that you've cited, Mr. Jain. I think, we can get a clear image in our minds as to, what different innovative ideas can be used to reduce the weight and, while also keeping the costs in check. And you mentioned about, it being like an amalgamation of material as well as, CAE techniques. So coming, taking from there, the topic of technology. And what role is technology playing today in terms of, as an engineer, in terms of making you achieve the right design, optimizing the weight of the component, and how is technology enabling an engineer today in achieving all these targets?
So I think a lot of let's say mm, uh, you know
say if I look at even like digital twins, or if I look at CAE techniques, I think CAE now with newer CAE and let's say a hybrid CAE and AI models are able to do what I think otherwise would have been a very long iterative process. Now with these newer techniques, you are able to make, let's say, make assumptions. You're able to make designs and virtually test these designs, and thereby reduce or the lead time for some of these new ideas, and also reduce cost, right? I mean, you can do a lot of these iterations now, like digitally, test them, see how they perform on different scenarios. So there's also a lot of multi-physics CAE that goes on now, where you can do thermal, structural, even electronics, all in a combination. And this multi-physics CAE is able to do all of this that otherwise would be a very long, iterative, expensive process. So technology definitely helps in these areas. Also, a lot of work that we are doing on material science, where different alloying, different working on different like different materials, and these all also, there's a lot of now like digital databases that are available, which you can feed into CAE models, and also thereby, so yeah, a lot of technology element now, or tools, let's say, are now available for you to do a much faster, more reliable outcome. Yeah.
Right. And if you can elaborate a bit more on just the AI aspect, Mr. Jain, how do you see that evolving in the entire engineering approach right now? Because, AI also looks at a lot of historical data that you might have internally and then suggests you possible options and, more alternatives. So what role is that playing right now, and how are engineers sort of uh, attuning themselves to work with AI in a collaborative fashion rather than sort of competing with it?
So at Minda, we have four different, let's say, verticals of AI usage, and it's an evolving field. I wouldn't say that we are there using AI in the most optimal way. We are also learning through the process, but there are four, let's say, themes that we are working on. One is generative design, yeah, and this is where, as you said, there's a lot of historical legacy data that we have, and feeding them into models, helping us, like come out, increase reuse of certain design and concepts, and thereby reducing the lead time and improving the accuracy of designs. Yeah, so this is something that is one theme that we are working on, which is use of generative design in CAD, and in like design of mechanical parts. Second is using of AI extensions in CAE. So that's what I was talking about, more of combination of AI and CAE. This is where using again a lot of artificial intelligence, you can improve the accuracy, improve correlation of your CAE models. Third is using AI also for failure mode analysis. So this is again where there's a lot of data that's available, which helps you zero in on possible failures, failure modes, even help you in terms of, say, like problem analysis and finding possible, say areas of failure severity, and these kind of things can now be assessed more easily. And finally, the area of finding, or like capturing requirements specific to a region, specific to a, let's say, a usage. So there are models that you can now use AI in order to do better in terms of capturing requirements. So these
Right.
are 4 different themes that we are using AI on, or
Right.
right now in the process of developing them, let's say.
Right. And like you said, it's an evolving process right now,
It is
and going forward,
absolutely,
I think it's only going to get more augmented. Right.
absolutely.
Right. Mr. Jain, also, if you can give me a trend, in terms of the materials that you see in the automotive space going forward. If you can take some examples from your domains itself, what sort of materials trends do you see going forward? And also, the challenge around the availability of those materials locally in India. So if you can shed some light on that.
So I think one is low density alloys. Yeah, I mean, then these are there are some novel low density alloys. There are things like magnesium and others. So this is one. One is, I think, looking at more and more low density alloys, and there's a lot of work that we're doing in the area um uh, of creating new alloys itself,
Okay.
which where you can use you can reduce reliance on imports and others, and still come up with compositions which you can localize in India. Yeah.
Right.
Second is usage of high strength steel, and this is again in automotive, a great trend where you could use them for lightweighting and use them for structural components, and use more and more of high strength steel.
Right.
Number three is, I think, in advanced materials like say like carbon reinforced materials. Um, Third and fourth is, I think, in composites. And composites are again, coming out in a major way where you could use composites from even for structural parts, like say, for example, we're doing work where we're using like paper reinforced composites, where you can uh, even make a roof of a car with respect to like paper, honeycomb, like honeycomb structured papers, where
Right.
you can use them for seat berths in trucks. You can use it for roofs, and which is maybe 60% lighter or 50% lighter, and these kind of things. So more of composites, and looking at it. And the last is lightweight polymers, and these are again polymers that with unique composition, where you can even add things like even air bubbles and epoxy materials in order to reduce the total weight, or use glass fibers and
Right.
glass beads in epoxy material, thereby also reducing weight. So
Right.
yeah, so a lot of these, again, in terms of polymers. So these, I would
Right.
say, 5, 6 areas that I
Right.
believe are the key trends.
Right. And although you mentioned earlier about the different manufacturing processes that are being leveraged to sort of compensate for the cost increase by reducing the cost in the manufacturing process, but an obvious question which comes from these material trends that you've just shared is the structural integrity itself. So I mean, from a layman perspective, there could be a sort of a reluctance towards these materials from a crash perspective. So how do you address that sort of a challenge?
I think there is, again, as I said, CAE to the rescue, and then obviously finally you do put them to a lot of tests. But I think right now in the whole area of CAE, it can easily be proven that you could have some of these new age materials being used for really like critical applications, where
Right.
even crash are involved, and still showcase that they could even improve crash resistance in many of these cases.
Right.
I mean, using, say, for example, blow molded like crash absorption like parts are very simple and very effective in terms of even improving crash resistance or crash absorption of
Right.
impact. So there's a lot of, I think, scientific tools now to be able to prove that these
Right.
materials can be
Right.
used.
Right. And what about the formability, Mr. Jain? I mean, the manufacturability aspect of these materials. I mean, is that also a challenge that the industry needs to address?
Yes, I think since these are new age, let's say, not being used in as much volume as the legacy materials are, so costs are currently higher.
Right,
Manufacturing technologies are not very easily available, and these do pose a barrier,
right.
and that's where I think there's a lot of work where of trying to create volumes, trying to create supply base and supply ecosystem for this is something that we constantly work on, and it's an industry challenge
Right.
to be able to work. So as the volume and the usage of these increase, the cost goes down,
Mm-hmm.
and but there is a time span where there will be an impact in terms of higher cost and low availability of supply base. So this is something is a challenge, and I think a lot of tier ones like us are working through them.
Right, right. And another element that I want to touch upon, Mr. Jain, is that of sustainability. Now, since we are transitioning into some newer kind of materials, so is sustainability also a big criteria in today's time when you are looking at exploring some new or some alternative materials?
Yes, absolutely. I think many of these, right, if I look at it from a recyclability perspective or
Right.
a reuse perspective, end of life perspective, I think these are very important aspects now, which are becoming more and more as a standard practice to look at for automotive companies or automotive tier ones like us. So, the example that I spoke to you earlier about where we are replacing epoxy with, say, a low pressure injection mold. Epoxy is a non-recyclable, like product. You can't recycle it, and
Right.
it is not something that we would term as sustainable. And moving to a low pressure injection molding makes it immediately a more sustainable option. So there are several areas like this where usage of say non-sustainable materials and replacing them with recycled, the regrinded, a mixture of recycled material versus virgin material. These are again now and more of a common practice for us to build in all these initiatives that we do.
Right, right. And when we look at some of the electronics intensive components, so with the changing E&E architectures, we are seeing this shift towards zonal controllers. So that
Yeah.
consolidation of the entire E&E architecture, Mr. Jain, do you think that also is going to contribute towards sustainability as well as lightweighting?
Definitely, I think lightweighting absolutely, because now if you look at the number of ECUs in a car versus what we see happening in the future, yeah, so you do see more than 20 ECUs get consolidated into, say, 4 or 5 domain controllers and zonal controllers. So that definitely reduces the weight. Although there is now more electronics also coming in, from just one camera in a car to 8 cameras in a car. So there are other
Right,
aspects of electronics that also gets added. But
right,
at the end of the day, I think there is a net, let us say, reduction in weight, and thereby also it's more sustainable from
hmm,
other aspects, right? I mean, it is contributes to lightweighting. There is lesser usage of say non-recyclable components and parts that go into this, lesser number of PCBs that are used, lesser number of ICs that are used.
hmm.
So all these definitely at the end of the day do contribute. And yes, electronics trend of like centralization and domain controllers and zonal controllers definitely is contributing to that trend,
Right,
or is going to help that trend. Yeah.
right. And is software also playing a key role here, Mr. Jain? I mean, you have a
They
tech
go hand
solution.
in hand.
Right,
They definitely go hand in hand. When you move from some of these say discrete ECUs to zonal and central architectures, software becomes a more dominant like component or a part to it, and thereby also make sure. So, say for example, the life cycle of a car, right? I mean, right now, or maybe 5 years back, when you used to buy a car, it used to undergo zero upgrades in your 5 years
Absolutely.
that you used to own that car, or the 6 years that
Yeah.
you used to own the car. And now you will see that there is an upgrade your car is receiving every year, and
Yeah.
thereby keeping it as fresh like a phone, keeping it
Absolutely.
more up to date and more fresher, thereby maybe increasing the lifespan that you would own a car without feeling that it does not have a certain set of features.
Right.
Yeah, so it is upgraded, it's latest, and and hopefully you would keep it for longer, and that
Absolutely.
also at the end adds to a certain sustainability
Sustainability.
like model to it. Yeah.
True, true. Just lastly, Mr. Jain, if you can just give us some quick areas of intervention of lightweighting in an EV architecture. What sort of areas can be tapped into when you're looking at optimizing weight in an electric vehicle?
So very similar. If I take that whole trying to see that we are consolidating in the E&E architecture, we are consolidating more and more say ECUs. A very similar trend is happening on the EV powertrain side also. So if you
Okay.
look at historically, there used to be a motor, an inverter, a charger, a DC-DC converter, a transmission casing, and also a PDU, or which actually distributes power. These used to be discrete components,
Right.
and from something like 6 different components or 7 different components, it's now got consolidated into what we call as a six-in-one
Mhm. Module.
e-axle. And a
Yeah.
six-in-one e-axle has a motor, an inverter, a gearbox, a charger, all built into one single unit. And
Right.
the single unit is at least 30% lighter than its discrete set of components, lesser
Right.
wiring. So overall, it could contribute to nearly a 30-35% weight saving.
Right.
And so a very similar concept on the of integration of ECUs is happening on the EV side, as well. And this is not only happening on the EV powertrain, but it is happening similarly on the on the battery side. It is happening on the moving to say an 800-volt architecture. How does it
Mhm.
help? It helps in because you're going to be using lesser amount of cables for
Cable.
the similar thing. So these
Right.
all architectures of moving to higher voltage, trying to consolidate these different ECUs, go to domain controllers for EVs, are all trends again that lead to this or help in this overall
Right.
lightweighting exercise. Yeah.
Right. Right, right. Lovely, Mr. Jain. I think you've given us enough insights by means of some really good examples as well, and sharing all these enriching comments with our audience. Really appreciate you coming over and giving us a holistic view of the future trends that we can expect in terms of lightweighting in the ICE space as well as the electric vehicle space, and the use of technology in enabling all these lightweighting initiatives that the industry is taking. Thank you so much, Mr. Jain, for joining and taking your time out. Thank you so much.
Yeah, thanks, Mayank. Thanks a lot for having me, and it's been great discussing with you. Yeah, thank you
Thank
so
you. Thank
much.
you. Thank you.
Thanks.
And with that, we come to the close of this 2-day virtual webinar, Vehicle Lightweighting Conference, brought to you by Sika and powered by Pioneer India Electronics. I really hope all our audience members had a lot of takeaways from the 2 days of enlightening discussions with our experts from the industry. And we've really tried to answer all of your questions. The recordings of both the days will be available later on the Autocar Professional YouTube channel. So if you've missed any part of this seminar, and or if you want to go back and re-listen to any of the portions, you can log into the Autocar Professional YouTube channel, and you can refer to the video footages of the 2 days of the Autocar Professional Vehicle Lightweighting Conference. With that, we will like to take a leave and hope to see you next time. Till then, take care and goodbye. Thank you for logging in.